Good morning, everyone. That is today we are going to see about the architecture of 8086 as a lecture series of two. Uh, Normally, 8086 is 8-bit or a 16-bit processor. It is designed by Intel in late of 1970s, and it has a 20-bit address and 16-bit data, and also it has a 1 MB memory. And normally 8086 divided into segments registers. These segment registers are used to calculate the physical address along with the offset address. So based on this, the memory is divided into segment registers. Normally 8086 divided into two execution unit. This is a block diagram of 8086. It has two functional units. One is execution unit and next one is bus interface unit. Simply we can say it is a BIU unit and a EU unit. So normally a BI unit has access the physical address, that is segment register address uh, it fetches, and to calculate the physical address. And normally bus interface unit responsible for fetching instructions from the memory and decoding them, uh, the instruction what it has to do. And for the execution unit, it is execute the instructions based on the instructions. So BI unit also manage the data transfer from memory and memory IO devices, also for the microprocessor. So that is BI unit manage the data between memory, microprocessor and IO devices. And 8086 has general purpose registers, and it is available in the EU unit, and it is named as AX, BX, CX, IP, SP and all. And along with this ALU unit is there, and flags and operands are there in the EU unit. First we are going to see about the BI unit. In the BI unit there are uh, se- segment registers are available, that is extra segment, it is called a CS register, code segment and stack segment and IP segments and all, and data segments also there. So extra segment which consists of the which is consist the um, base address of a extra segment, and also for the code segment it consists base register of base address of the code segment, and extra segment and data segment and instruction pointer, that is instruction pointer, it point out the instruction sets. And these registers are used to calculate the physical address, and along with already I mentioned, along with the offset address, it is mentioned by the manufacturer. And 10Hs, for example 10H plus code segment, it mentioned the, and it is sent to the summation unit. It's before the unit, you can see it in the diagram. Here it is calculated the basic the physical address, and based on this the instructions fetches, and it is stored into the queue. The main advantages of the architecture of 8086 is it has a queue, that is the instructions are in the pipeline, that we called as the queue. So based on this, the instructions are executed in faster way, and the speed of the processor is to be increased. These are the advantages of 8086. And for the execution unit consists of it gives the instruction to BI unit to transfer the data, where to fetch the data, and then decode the execution units. Function of ALU, that we know that it functioning the arithmetic functions. And functional unit, it has that is ALU, it will handle all the arithmetic and logical operations of plus, that is addition, subtraction, multiplication, and the logical operations are and not, etc. Next, special function registers also there. We know that before that, a stack pointer register, it has a 16-bit register. It holds the address from the start of the segment to the memory location where a word was most recently stored on the stack. And One more unit is there in the execution unit. The execution unit has a flag register. The flag register tells about the status of the resultant that which is executed recently, executed the instruction recently, and store the information in the flag register. That is status in the, it is available, the status of the instruction is available in the flag register. The 16-bit register behaves like a flip-flop, that it changes its status according to the result stored in the accumulator, and it has 9 flags are there, and divided into two groups. One is conditional flag and control flags. Conditional flag represents the result of the last arithmetic or logical instruction executed. Control flags controls the operation of the execution unit. So under flag register, conditional flag, carry flag indicates overflow condition for arithmetic operations. That is from the D4th to D3 to D4th bit. Is there any borrow is there, then we call it as the auxiliary flag. And the parity flag is used to indicate the parity of the results. It is odd parity or even parity based on the number of ones is present in the resultant. And the zero flag set to 1 when the result of arithmetic or logical operation is 0, else it is set to 0. And the sign flag, it holds the sign of the result, which is a positive or negative, that we can say is in the form of that the sign flag is set to 1 or else set to 0. If it is negative, then it's set to 1 or else to 0. Over flag represents the result when the system capacity is exceeded. So that's all about architecture of 8086. I think you all learned more about this 8086. If you have any doubt, please ask me.